Hello everybody, this video is about networks. If you've got a network, or if you're at home, or if you're at work, you're probably using a network. So hopefully this is of interest, even if it's not relative to your Python career. So without further ado, let's look at what we're going to do today. So the problem is, the person in question needs to readdress their network to allow for more hosts. And when they created it, they didn't anticipate that it was going to grow so big, which is quite a common issue. And without doing lots of complicated into VLAN routing and getting into the nitty gritty of it, one thing you can do is change your subnet mask. Now, I won't go into it, but it's basically a way that you can do a logical AND using binary to filter what addresses can communicate. What we need to establish is, if we change the subnet mask at the site in question, will it compromise remote VPN access? And there are also some rented multifunction printers, which we need to establish, will they be able to be used by clients using the new address range? We're going to do a proof of concept using Cisco Packet Tracer. If you register with Cisco NetAcad, you can actually download Cisco Packet Tracer version 8. And if you use the correct router, i.e. a Cisco 1841, don't use the 1941. You'd think that would be the same, but it's not. Only the 1841 and I believe the 2811 allow you to simulate a VPN tunnel. And my friend who's got the VPN and maintains its network has a VPN IPsec tunnel in between his house and between that and school. His house is hut 6 and the school is called Skool. So what we're going to do is we're going to replicate the current network, and then we're going to modify all of the school subnet mask from 24, which gives 254 clients. We're going to change it to a /22 subnet, which potentially could give 1022 clients. So without further ado, let's have a look. Hello everybody. This is a one-off video today, so it's how to redesign a network, and basically we're going to allow more clients to join the network. We're going to expand the range. So if you'd like to see me do the example in Packet Tracer and prove the validity of the design, then keep watching. So we're going to be using Cisco Packet Tracer. You need to enroll for the course, I believe, through NetAcad, which is Cisco's training academy, and submit your details, log in, register, all that stuff, and you'll be able to get Packet Tracer version 8.0. So once you've got that, you can drag lots of icons of routers, laptops, switches onto the screen, and then you can configure them. This isn't a beginner's tutorial, so really I'm just going to talk through the overall concept. So what I've done here is I've added a school network which has a router, and then it has a switch connected to the router, and then multiple clients and a FileMaker server. Then we've got our typical triangle of routers from the school to the service provider, and then back to a remote location which has got a client laptop attached to it. And the first thing we're going to do is we're going to establish a site-to-site VPN tunnel between the remote location and the school. So that's what I'm going to do next. I'm not going to video it all because it'll be time consuming and boring. So I'll rejoin once I've done that. I'll demonstrate it, and then we'll look at how we're going to go about enlarging the IP address range at the school, and we will then see if it works. Okay, so sorry if the picture quality is not great. I gather that when you zoom in using Cisco Packet Tracer, it must be using raster, it's not using SVG, so some of the text is actually going a little bit fuzzy, but anyway, this is hopefully enough to show you what we're dealing with. So if we I'm just going to obscure that bit down there because that's new. There we go. So what we've got is we've got a school network. Hopefully you can read that there. That says school. I've shown 3 clients there. In reality, we've probably got 30 or 40. We've got a FileMaker server, and we've got 2 multifunction printers, and we've got lots of people with iPads and portable devices. And one of the issues is actually controlling the firewall rules and the filtering. And potentially a good solution would be to put all of the clients, all of the iPads onto, for instance, a network such as 192.168.3 or .2. And to do that and allow everything to still communicate, we would need to change the subnet masks from 255.255.255.0. We would change that to 255.255.252.0. Thus future-proofing it a bit and potentially giving us, as I say, 1,022 clients, which is more than you should ever need. Yeah, potentially this increases the size of the broadcast domain, and potentially you could get a slower network. But not all of these addresses are going to be used, and really this is more for ease of administration so that you could place your clients into a 3 network or a 2 network. It's a bit like having a guest VLAN on a corporate network, for instance. Anyway, we've got router here at the school. I've shown a ISP router, which, yeah, unless you're a network engineer, you don't really care about. That's just the internet as far as you're concerned. Then there's the router at hut 6, which is the remote location. And what we've got here is also we've got a 3 network. So one of the considerations is if we increase the subnet mask to allow more hosts here, and then we use a .3 network at the school, will that be a problem because we've got a .3 network at hut 6? And we'll shortly find out the answer to that. And the other consideration is if we add a new client here on the 3 network, will it be able to talk to the multifunction printer and FileMaker server? So let's consider what we want to do. We want to add a new host, 192.168.3.20. The .20 could be any number between 1 and 254. I've given it a .252 subnet mask, and I've also changed the FileMaker server subnet mask, and now it is 255.255.252.0. So, first question, I just need to update that note there as well. This is just text, it's not actual configuration. What I've showed you here, however, is configuration. So that's actually part of the simulator. Okay, so if we go over to here, what we'll do first is we'll verify everything within the school can talk to each other. And then we'll look at the VPN side of things because that's slightly more involved, should we say. So PC 0, so this is the PC in the little green square, which is effectively our additional network. So hopefully you can see this text. It's not massive, but I'm limited by what Packet Tracer can do. So from the PC in the green square, the new PC on the 192.168.3 network, I'm now going to try and ping the FileMaker server. So here we go, 1.60. And yes, we can ping it. And that is because I've changed the subnet mask on the FileMaker server. And now that is 255.255.252, as is the new PC. Now, what I've also done is to allow the hosts within the existing network to communicate to everything within this new expanded network. I've also changed them. So or I need to. To be honest, actually, let's just do it before we change. So I'll just show you this before. We'll do a before and after. So I'm on this laptop here, the left-hand one of the three, and it's currently on the 192.168.1 network. And I'll just show you that we can still ping the FileMaker server. Nothing's changed there really. So we'll ping in 1.60. There we see we can still ping the FileMaker server. So changing the subnet mask on the FileMaker server doesn't affect the existing clients. Right, so the next issue is, can the new 192.168.3 PC, can it communicate with a printer on the 255.255.255 subnet, which is how there's two printers here, and they're both currently configured just with the 255.255.255.0 subnet. So I'll just show you that, and that one's, I think I've only set one of them up. Let's just check. In fact, it's not got an IP address at all. That's a bit strange. Okay, so let's settings. Gateway. Just want to check the address. Static. 192.168.1.26, and I'm going to give it a 255. No, it's already filled that in for me. Okay. .0. So that, in a moment, that's just the old address, the old subnet mask. And then from PC, the new PC, can we communicate with the printer without any change to the subnet mask on the printer? Running this in Packet Tracer it is quite time consuming. So as you can see, it's not communicating. So that's because of the subnet mask is still set on 255.255.255. So if we change that in real life, obviously a man from Xerox or Canon would have to come out and do this, I would imagine, especially if the device is rented. So here we go. And now if we try and ping it from the new PC, we get a reply. So opening up the subnet mask on the printer allows the PC in the 192.168.3 range to communicate with the printer. So that answers one of our questions. One of our questions was, will we still be able to communicate to the existing printer if we add a client on 192.168.3? And the answer is we won't, not unless we change subnet mask. So this 255.255.255 will need to change to 252 for it to work. And same for that one. I've just shown two printers here because I gather in real life there are actually two in the building. Good. Right, so we've covered adding a new PC, changing the subnet mask on the FileMaker server, and adding an additional PC in the 192.168.3 range. Now, interesting question. Will this break anything for the remote client connected over the IPsec tunnel? And let's just check. So again, this is the Cisco Packet Tracer simulator. And what we've got here is effectively we've got a simulation of the DOS prompt on, yeah, I know, a Windows laptop at HUT 6, believe it or not. So at HUT 6, if we ping, we'll ping the FileMaker server, which is now using the new subnet mask of 255.255.252.0. So from the HUT6 PC, we will try and ping the FileMaker server. And I've not put a full stop there, that might help. And we're connected over an SSH tunnel. Let me just prove that that is the case. So whilst we're seeing successful pings there, I just want to show you so we've got skool. It's time, right, show. This is how you check VPN traffic on a Cisco router. So show crypto IPsec SA. There we go. So at the moment you can see packets encapsulated 25, packets decapsulated 26. So if we run some more pings from HUT6, we should get another 4 pings. And when those 4 pings have completed, 1, 2, 3, waiting for the 4th, just down here, look. Right, so that, now our VPN traffic, that should increase from 25 up to 29, hopefully. Yes, there you see, it's really small, but it says 29 there and decaps. The reason why decaps is one more than ncaps is something to do with ARP requests, which I can't quite remember, but trust me, it's not a problem. There's always one different. I think it's because the first ping request always gets timed out. Right, so we've proven, let's go back to our initial presentation. And the question was, does site-to-site VPN still work from 192.168.3 network at HUT6? And the answer is yes, yes it does. Will the multifunction printers need subnet mask changing to 255.255.252 to allow new clients on the 3 network to access them? And the answer is yes. So hopefully that's cleared it up. I'm just giving you a bit of an insight into how IP networks work and how you can simulate them using a program called Cisco Packet Tracer. And to be honest, although this is proprietary Cisco software, you can actually simulate any network devices. So if you had an HP or an Aruba, you could just drop in a little Cisco icon and give it the IP address and the subnet mask. And as long as you're just checking connectivity, you can pretty much simulate another manufacturer's device. Effectively what you're checking is end-to-end traffic. And even an IPsec VPN tunnel, you can also do that. You could simulate that because in theory, an IPsec VPN tunnel will work between different vendors. It all adheres to the same standard as long as you get your keys and your passwords correct. I haven't shown how to configure that, the IPsec VPN tunnel. It's beyond the scope of what I need to show here. If anybody's interested, I can do a tutorial on that. If you just want to get back to watching me do things with Python, then just don't give us a thumbs down because it's not helpful. So hopefully this has helped any of you who are interested in IP networks, IPv4, VPNs, subnet masks. And remember, it's all the underlying concepts are pretty much the same. It's doing a logical AND. The IP address and the subnet mask does a logical AND. So even if you're a Python programmer, logical AND is something that you will come across. You might not ever need to use, but certainly if you ever look at I believe it's the official Python certification program, that covers bitwise comparison. And yeah, bitwise comparison is something that you'll come across if you get any more involved in programming. So thank you for watching, and hopefully this has cleared up a few sort of question marks that you may have about networks, or I may have just given you even more questions about networks, in which case, don't be shy, drop me a comment. Thanks for watching.